A very good day. This is Mrs. Shaila, Assistant Professor, Department of Mathematics, SNS College of Engineering. Today I am here with the continuation of the previous lecture video. You all know that in the last video we saw about Statistical Quality Control. There we discussed what is Statistical Quality Control and how do we check a quality of a product. For that, we saw we have two types of charts. One is based on common cause, the other one is based on attribute cause. We saw what is common cause, and in common cause we started about X chart and R bar chart, and we had a clear picture about X bar chart, and we finally saw that X bar chart lies outside the control. Now we are going to see about R chart. R chart means range chart. That is the range of when you choose one product. In one product I take 5 samples. In that range means highest value minus lowest value. The range is already been given. So the data is being tabulated. It is given here. How to calculate the chart? As similar to X bar chart, first we need to know what is X bar value and R bar value. We saw how to calculate it. X bar means sum of mean values divided by number of terms. R bar means sum of range value divided by number of terms. So already we have calculated and the value is 136.75 for X bar and R bar it is 42.75. So this is already been calculated. Now the things needed for R bar chart is, first before going for calculation, from the quality control chart that is available, you need to take the values for D3 and D4. It is quality values. We call it as tolerance value or quality value. The value for D3 for a sample size of 6. This was the sample for one product. So for 6 it is 0 and D4 value it is 2.115. After writing that, as similar to X bar chart, you need to know what is CL, LCL, UCL. CL is nothing but R bar, which is equal to 42.75. LCL formula is D3 R bar. Since D3 is 0, you get LCL value to be 0. And UCL is D4 R bar. D4 is 2.115 multiplied with R bar, it is 90.41. Now with this data and the range data, we are going to draw the R bar chart. We have found out the UCL, CL and LCL value. Now proceeding with the chart. Chart your x-axis and y-axis. For x-axis you have to take sample number. So I have taken the sample numbers. We have 12 samples. So 1 to 12 I have taken 1, 2, 3 up to 12. Your y-axis you are supposed to plot for the range. Your range least value starts from 30. So I have taken 20, giving 10 units in between. So I have taken it as 20, 30, 40, 50, etc. up to 100. So for this, now we are going to plot sample number versus range. So for the first sample, the value is 30. For the second, it is 42. So I have plotted all the values. With that, first the central line. Central line is 42.75. So I have drawn the central line. I have given a difference by giving dotted lines. Then lower control limit. Lower control limit is 0. So I have taken in the x-axis. And upper control limit is 90.41. So I have plotted for 90.41. Just for color change I have given with different colors. Now plotting sample number versus range, I have plotted all the points and connected all the points. When you see this graph, you can see that all the points lying inside the control. So we declare that all the range values are in control. So X bar chart is out of control, range chart it is in control. Using this you can find out the tolerance. Now if you see this chart, from the chart we are declaring that all the points lie inside the control limit. But before drawing the graph itself, you can decide whether the values, whether the chart, range chart is going to lie within the control or out of control. That is, see your range value. Your range value starts from 30 and you can understand whether it lies inside or outside. Okay. So let me see the next set of